First generation technique, we have exploratory and confirmatory. You need to listen to this discussion. We have people who don't understand what is meant by exploratory analysis and exploratory research. Two different things. Exploratory research, you don't have hypothesis. Correct? Exploratory research, you don't have hypothesis. You go and look at the phenomenon, then you come out with some idea, then only you develop hypothesis. That's called exploratory. Whereas exploratory analysis means you have a model to begin with, but you want to explore how to make the findings better. So you have some relationship not in the model, you want to test also. So that's what we call as exploratory analysis. Okay, exploratory analysis. So when you do analysis, we can have two. One is called confirmatory analysis and exploratory analysis. So for exploratory analysis in SPSS, you can use cluster analysis, EFA, and multidimensional scaling. Okay. For confirmatory analysis, you can use ANOVA, regression, multiple regression, and all. In SPSS, we can also use confirmatory factor analysis, but we can only run one variable by one variable. We cannot run all variables together. That can only be done in structural equation model. Okay, structural equation. So when we move to second generation analysis, we also have the exploratory and confirmatory. The exploratory software, we call them variance-based set, which is PLS. All this PLS variation. And we also have confirmatory ones, which are called covariance-based set. Your MOS, your M+, all on the right-hand side. Okay. So we have these two variations. We need to decide which one you want to use. Are you trying to explain, or are you trying to fit your data to the theory? You have to decide that first before you pick the software. So what are the software? I will explain a bit later. So the first generation, second generation analysis. What is the difference? Okay, what is the difference? So when we do first generation analysis, we also do factor analysis, correct? Okay, every time you do primary data research, you need to do a factor analysis, which is called the construct validity. Remember, just now I was telling you, at the theoretical level, we have a variable. Now we are measuring that. We want to know how good is the measurement, right? That is what we call as construct validity. Okay. So for construct validity, we have a test called factor analysis. Okay. Factor analysis, we have two variations. Okay. Number one is EFA, and number two is called CFA. Okay. I used to ask many PhD students, why do you call EFA? Okay. Nobody seems to be able to answer. Okay. Let me explain why. Okay. When we run the EFA, like this, we have this variable called job satisfaction, right? We have a variable called organizational commitment. Based on your theory, job satisfaction leads to commitment, correct? Okay. Now we measure job satisfaction with 3 items. We measure organizational commitment with 3 items, correct? Okay, 3 items. So if you run EFA, what will happen is you put all these 6 items together, and the software will tell you which item falls into which dimension, right? So when you run the analysis in EFA, you will get like this. You see component 1 and component 2, right? It doesn't tell you the first variable is what, second variable is what. You need to label them because the software will not know which item measures which variable, right? So if you get a result like this, very nice, right? JS1 all very nice. OC all become 1. So you can label component 1 as job satisfaction, component 2 as organizational commitment. If you are lucky, and this is only 6 items. Imagine you have 100 items. Okay. Okay. What normally happens is like this, Serena, right? Like this. So 2 items fall on this, and another item JS is falling on the other side. Okay, 2 items here, right? And then 1 item falls here. Here we have 2 items nicely, and 1 item is on this side. Okay. The reason is because the software doesn't know which item measures which construct. Correct? In EFA, you put all the items together. The software will decide which item falls on which variable based on correlation. So when we do EFA, we are statistically driven. There's no theory. So that is why we have a term in Penang called rojak pasembo. You know what is rojak pasembo? Huh? They put all the ingredients together, put the gravy, and then they mix them up. Huh? So this will happen. So if you have 100 items and you run them together, everything will go everywhere because you are not able to tell the software this item measures this variable in EFA, SPSS. But when you run your model in CFA, what happens is you draw them like this, right? You're drawing them, telling them job satisfaction is measured by JS 1, 2, and 3. Organizational commitment is measured by OC 1, 2, and 3. Now the software knows, right? Which item measures which variable. So what will happen is this item cannot go here. This item cannot go here. Cannot switch because they are already assigned to the construct. And in Smart PLS, what will happen is when you run your factor analysis, they will give you a result like this. They will tell you job satisfaction, JS1, JS2, JS3, organizational commitment, OC1, OC2, OC3. How do they know this label? Because you already label here. Remember? You already tell the system JS1, 2, 3 is job satisfaction. OC1, 2, and 3 is this side. So they will know which item is measuring which construct and they will assign them there. Okay. What will happen in this analysis is either they remain here or you delete them. They cannot go on another factor. Whereas in SPSS, this can happen, right? One item can go another construct. This is what we call as cross-loading. And that is the basic difference between EFA and CFA. Okay. We have been doing EFA for a long time, no? Because we learn SPSS. In SPSS, you can only do EFA. Cannot do CFA together. Okay? And this is not required anymore. Most of your constructs are taken from somewhere, correct? Okay. When you write your chapter 3, sometimes I think to myself, last time we were actually really stupid. We follow the instructor, right? In your chapter number 3, you write clearly, right? Construct A has 3 items taken from this source. Construct B, 3 items from this source. Construct C from this item, this source, right? But when you go to chapter number 4, you have temporary amnesia. You forget, right? You say, I don't know. Huh? Now let me run with EFA. Now the EFA reassigns everything, right? Okay, that's the problem. We never question the instructor, but we just follow. So that is where in many years ago, you have in chapter 4 revised framework because item run everywhere, right? Some variable get deleted and all. But now it doesn't. No? Variable will retain the same. Only item get reduced. Variables will be the same. Huh? Only let's say you start with 5 items, maybe you delete 1 item here or 2 items. That's what is happening with CFA. Okay. So understanding of these differences is important because you may get an examiner who will say, why didn't you do EFA? And the argument is culture. Instrument will work the same in any culture. Except when the instrument is related to culture. For example, you want to measure ease of use, right? Ease of use. Are you saying ease of use in China is different from ease of use in Malaysia? Cannot, right? Ease of use is ease of use, right? It must work the same for population in China. It will work the same. That is why we always start with the theory, remember? Theory transcends borders. Theory works in different settings. Okay. Sometimes the item don't work well because of language. Because the original instruments were all developed in English. And now you're collecting data from people who don't speak English as native. That is where you need to think about translation. We have Brislin, right? Back-to-back translation, those kind of things are available. Those are processes you need to understand why you need to do. Instruments will work the same. If the respondent understands your questions well, instrument will work in any setting. Most of the time, misunderstanding of the term. That is why it's causing items to get deleted. Okay? Yeah, any question? Yeah, on the WebEx, anybody has any question? No question. Okay. I actually like to draw, but if I start drawing, the WebEx people will have a problem. So that's why I have all the slides here. We had an update. Okay. This is already updated version. So you can install from here also. Then these are the software I was telling you. What PLS, SAM in R. If you want to explore, you can look at the folder. Okay, at the bottom, we have some Excel templates. Later, when we do the hands-on, we will use, for second order, we will need to calculate A, B, and CR. We will use this. I've also added one more calculator here for mediation effect size. Previously, we don't have a calculation for effect size in mediation, but now we can do that. Now we can do that. Okay, so those are Excel files you have in the folder. Okay, so those are for materials you already have. Okay. Now we come back to our discussion. Okay, yeah. So for comparison between your partial covariance-based SAM and variance-based SAM, this is side by side. This is a paper called Urbach and Ahleman in 2010. They put this as objective, approach, assumption, everything. But I have highlighted three components which are important for you. Okay, number one is model complexity. Large complexity models can work with PLS, but for covariance-based SAM, small to moderate complexity. I already mentioned 7 construct, 50 items. Anything bigger than that is already considered complex. Okay, number two, sample size. Here they are still going back to the issue called power analysis. So we have a software called G-Power. Based on G-Power, you can calculate the minimum sample size. Any sample size larger than that number is okay. Anything less than that number, no good. Okay, no good. That's how we decide on the sample size. And number three is also important to understand, called optimization. Okay, the difference between your covariance-based SAM and partial least square SAM is, in covariance-based SAM, let's say you have 5 independent, 1 dependent. All these 6 variables must fit together as a theory. All the 6 variables. Whereas in PLS, we are trying to maximize 1 independent and 1 dependent first. Then we move to the next one. Okay. Locally iterative compared to globally iterative. That is why in covariance-based SAM, if you have 1 variable not very good, the whole model fails. Okay, the whole model fails. Okay, any questions on the comparison? Okay, G-Power you can use for non-random sampling because you don't have the number to begin with. Okay, you don't have the population size, right? You don't have a list. If you have a list available, you can stick to your Craigie and Morgan or Umar Sekran, right? Correct? You have, based on your population, this is a number. But the number must represent the population. The way you select is important, not the number. Okay? So G-Power is mostly, we don't know. We need a certain number to test the model, right? What is the minimum number needed? That's why we will do power analysis. We will do power analysis. Okay. Yeah. Yeah. Any other questions before we look at some of these names? So for those who are using partially square, these are some of the big names in the area. Okay, this is Christian Ringler on the left-hand side. You can see, right? Christian Ringler, and this is Jörg Hensler. 2011, I actually went to Hamburg for the first time to learn Smart PLS. Okay, 2011. So I'm quite lucky in that sense because I've attended workshop with people who actually developed the software. Okay, and that's a good thing because you know what they're actually talking about now. And this was not funded. I actually paid my own.
I have a question.
Yeah.
This particular slide that you're showing just now, the 8 errors, right? Okay,
Yeah.
these are the items, right? These are the items,
Yeah.
8 items pointing to a latent variable.
That's regression also lah, sudah.
Okay.
That's regression at the item level. Formative.
Okay.
Formative.
Formative.
The
Alright,
second
okay,
one
thank you.
is regression at the construct level. So we have two levels, right?
Yeah.
Both are regression.
Okay.
So
Okay.
we are looking at the biggest regression
Okay, the biggest regression. All right.
anywhere in the model. Anywhere in the model.
Mm.
Okay.
Mm-hmm. Okay. Thank
Okay.
you, Prof.
Okay. So
Prof nak tanya,
yeah.
kenapa dekat G Power tu ambil F test tadi ya?
Because you are testing this, kan? In regression, the most important table, in regression, we have two levels, right? First, we
Okay.
test whether we have a model, then only we test individual hypothesis. So the whether you have a model or not is overall, F test. The individual
okay.
variable is T test.
Alright, faham. Okay.
Okay? Individual variable is T test. So two different levels. Okay. And finally, we have this missing value. When you have missing value, what do you do? Yeah, when you have missing value, what do you do? You make don't know lah. Hopefully nobody knows lah. Correct? That's the strategy lah. Okay. If your sample size is large, never mind lah. 400 sample, right? You are missing value, okay lah. But if your sample size is smaller, like 80, then you are missing value, you need to address. Okay, you need to address. Less than 5% missing value, no need to do anything. Less than 5% missing value, okay? No need to do anything. Anything greater than 5%, you need to think about replacement. Okay, you need to think about replacement. So in the list I gave you, number one is the one many people do lah. You don't replace with anything, just run the analysis. Hopefully nobody questions you lah. Okay. Number two is like this. In your model, your scale is 1 to 5, right? Okay. Yeah. Okay. Another few more minutes, then we can take a break lah. Okay. I'm the one talking. Sometimes I don't understand. Okay. Okay, midpoint of the scale. What is meant by midpoint of the scale is this. Your scale is 1 to 5, right? The midpoint is 3, right? Any missing value you replace with 3. Okay. Any missing value you replace with 3 lah. Midpoint. Okay. Number 3 is random number. Let's say you have 7 point like a scale. You write 7 numbers, put in a box, you pull out one number. You get 7, right? Everything you replace with 7. You cannot put back and take one more number you like lah. That's not random anymore. One time only take out. That's number 3. Okay, number 4 and number 5 is mean value. We have two types of mean values. You know that, right? Okay, like this. Okay, here we have 3 respondents who answered question 1, question 2, and question 3. 1, 2, and 3 measures the same variable. Question 1, question 2, question 3 measures the same variable. Okay, respondent number 1 answered all questions. Respondent 2 answered question 1 and 3, did not answer question 2. So we want to replace question 2, right? We can take the mean value of other responses of the same respondent. This way, right? So 4 plus 4 is 8. 8 divided by 2 is 4. So we replace with 4. That's this way, Otherwise, In the third one is mean value of other respondent. So question number 3, out of the 3 respondents, only 2 answer, right? 2 and 4. So 2 plus 4 divided by 2, you get 3. So you replace with the 3. Okay? Those are missing value replacement suggested in textbook. They are all no longer acceptable. You cannot do them. Okay? Semangat dengar. Okay. Cannot do. The one you are supposed to do is this. The B and C. We have expectation maximization and multiple imputation. Multiple imputation slightly more challenging. So I have started using this method called expectation maximization. This you have to do in SPSS. Okay, SPSS. So when we run the SPSS, we have this function called missing value analysis. Okay, missing value analysis. We can actually use this method called EM to do the replacement. Okay, and I've started using this for some time now. Okay, EM. So I give you the screenshot you can look at it. No? Okay, the SPSS I gave you, I didn't install yet. No? Can you open your SPSS that I gave you? Can you find the missing value under